Welcome to Sir Robert Chiduk Tutorials. Learning is 24/7. Hello and welcome to Sir Robert Chiduk Tutorials. Today we are looking at the physiology of sight. Since last time we covered the physiology of hearing under the special senses, today I thought we should focus on the physiology of sight, which is also part of the special senses. So physiology of sight, here we are going to learn how somebody sees, how someone is able to visualize an image, how light travels, how objects within the field of vision are finally visualized, particularly in the brain, in the visual center, which is in the occipital lobe. So today we look at physiology of sight. So physiology of sight, generally light waves travel at a speed of 300,000 kilometers. Can you just imagine? 300,000 kilometers per second. So light is very fast. So this is what happens. So the first thing that happens for you to see an object which is within the field of vision, for you to see anything that is in front of you right now, probably there's a tin, probably there's a cup, probably there's a plate, or maybe there's just something that you are seeing right now. For you to be able to see that thing, the first process that happens, this whole process uses light. So what happens is that the light travels in a straight line, right? So the first that light falls on that object that you are seeing. So now when the light falls on that object will reflect the light. So the first thing that happens is that the light is reflected into your eyes. It's reflected to your eyes, right? So light is reflected into the eyes within the field of vision. White light is a combination of the colors of the visual spectrum or the rainbow. So there are certain colors that you cannot see, and there are certain colors that you see. The colors that you're able to see, those are what we call the colors of the visual spectrum or the rainbow. You know the rainbow, right? All the colors that appear on a rainbow are the colors that a human being can see. We call them the colors of the visual spectrum. Another word that we use is called ROY-GBV. ROY-GBV, which is an acronym for red, orange, yellow, green, blue, and violet. So this is demonstrated by passing the white light through a glass prism, which beams the rays of different colors to a greater or lesser extent depending on the wavelengths. Red light has the longest wavelength and violet has got the shortest wavelength, as you can see, right? So all those are the colors of the visual spectrum or the rainbow. This range of color is the spectrum of visible light. In a rainbow, white light fall broken up by raindrops which act as prism and reflectors. So the colors of the rainbow, we can call it the electromagnetic spectrum. So the electromagnetic spectrum is broad, but only a smaller part is visible to the human eye. So let us look at refraction. White light is broken into colors of the visible spectrum when it passes through a prism. Let's see that process. So don't worry, I will summarize the physiology of sight for you to be able to grasp it. I will summarize it. Here I just want you to grasp the main concepts that take place. So this is the beam of light white. Now when it is passed through a prism, it's producing red, it's producing orange, it's producing yellow, it's producing green, it's producing blue, it's producing indigo, it's also producing violet. So all those are the colors of the rainbow, what we call the colors of the electromagnetic spectrum, or the visual spectrum, colors of the visual spectrum. These are the colors that you see. There are other colors that you can't see. Right? I think you've seen them. So this is our electromagnetic spectrum. We have long wavelength and we also have short wavelength, right? So the spectrum of the visible light, you can just see that it's just very small. You only see a small portion, the visual spectrum, where you see the RGB, those colors, red, blue, indigo, yellow, and others, right? So there are certain wavelengths that you cannot see. For example, red waves, you can't see them. Microwaves, you can't see them. The infrared rays, you can't see them. The ultraviolet rays, you can't. X-rays, you can't. The gamma rays, you also can't see those ones. So this is I want to illustrate the concept of refraction. To refract is to bend. To refract is to bend. So now light travels in a straight line, as you can see. Look from here. Let me highlight for you to be able to see. Light moves in a straight line, as you can see here. Right? So when it reaches the lens is this biconvex structure. This biconvex structure. So when the light reaches the lens, because it is a biconvex structure, it is able to refract, which is to bend. It is able to refract the straight light rays, bend them. What is the main purpose of bending, of refracting the light rays? The main reason is the light rays move in a straight line. So if they continue moving in a straight line, the image will not be able to be focused, right? So now that the light is moving in a straight line, the function of the biconvex lens is to refract or bend the light. As you can see here, it's bent, right? It has been bent and focused here, right? The main issue was to focus here. This whole light was focused here, right? Because there was refraction, right? So I was illustrating the process of refraction, because there are main concepts that work in the physiology of sight. We have reflection, we have refraction. There's a difference between reflection and refraction. Reflection of light is a different process. Refraction is when the light rays are bent so that they are able to be focused, right? So when the light rays pass from a medium of one density to a medium of a different density, they are bent. For example, in the eye, the biconvex lens bends and focuses the light rays, right? So the function of the biconvex lens is to bend the straight light rays and focus them on the macula lutea, which is where the photosensitive pigments that generate the electric impulses are found, right? So when the light passes successively through the conjunctiva, the cornea, to the lens will refract the light rays and focus them on the macula lutea, which is in the retina, right? For the purposes of generating an electrical impulses which is sent to the brain for evaluation of sight. So this principle is used to focus light on the retina. This I said already. Before reaching the retina, light rays pass successively through the conjunctiva, the cornea, aqueous fluid, lens, and the vitreous board. They are all denser than air, and with the exception of the lens, they have a constant refractory power similar to that of water. Right, so what is the next concept which happens after refraction of light? After light has been refracted, another concept which then comes is the concept of focusing. The concept of focusing, right? Are you really following? In the first place, light was reflected within the field of vision. The light which was reflected within the field of vision was moving in a straight line right into your eye, right? In the eye, it moved successively through the conjunctiva, the cornea, until it reached the lens. Now the lens is a biconvex structure which has got the capacity and the ability to bend or refract the light rays that are straight, and to be able to bend them. So the next thing which happens now is to focus. Now the light rays have been refracted, but then what happens? They're supposed to be focused on a particular object. So here there's focusing of an image on the retina. So once the light rays have been bent or refracted, they are now supposed to be focused on the retina. So here the light rays reflected from the object are bent or refracted by the lens when they enter the eye, in the same way as shown in Fig. 8.16. Although the image of the retina is actually upside down, the brain adapts to this early in life so that objects are perceived the right way, right? So we are going to see all this. So what is a lens? A lens is a biconvex. A lens is a biconvex structure. A lens is a biconvex structure, right? You need to know the lens. The lens is a biconvex elastic transparent board suspended behind the iris from the ciliary body by the suspensory ligament. It is the only structure in the eye that changes its refractive power. Light rays entering the eye need to be refracted to focus on the retina. This I said. Because the light rays are straight, they need to be refracted, that is to be bent, and focus on the retina, right? Light from distant objects needs least refraction, right? And as the object comes closer, the amount of refraction needed is also increased. So the light that is coming from a very distant place will need minimum refraction, right? It will not strain the lens. But the one that is too close, if someone, maybe, let's take for example, if you put your something just near you, are you able to see it? It's very difficult to clearly see that thing or visualize that thing. But as you take it a bit further, you're able to see without straining your eyes. But if you do this, how can I see? You are sort of straining your eyes because the accommodative power that is needed is too much. And it's very difficult for your lens to be able to refract the light and really focus it. So it's very, very difficult. So there's a particular distance which is needed, right? Yeah, so all in all, I think I've been able to show you, to illustrate the concepts that take place in the process of physiology of sight. So now I'm going to give a summary of physiology of sight. Some of you wonder why I don't use the PowerPoint to teach. I don't use PowerPoint. Why? Because PowerPoint has got a few points and it's difficult, for example, for you to be able to master certain concepts. So I bring this book, this is Ross and Wilson 11th edition. I bring all the concepts as they are so that you're able to see. Then after going through, I then break them down and give you a summary. So that summary is what you are supposed to master. But you have gone through the critical concepts that are needed. So now let me just rush and describe the physiology of sight for you. So this is your physiology of sight, right? The first thing is this. Light is reflected by an object within the field of vision. That is your first point. Light is reflected by an object within the field of vision. This light moves in a straight line, right? This light moves in a straight line, right? So the light will pass successively through the cornea, through the subconjunctiva, the cornea to the lenses. When it reaches the lens, which is a biconvex structure, the light is going to be refracted. The light is going to be refracted or bent. Right? Another point, when this light has been refracted or bent, it is going to be focused on the retina. The retina contains the photosensitive pigments or the receptors for vision. So there's generation of electric impulses which are transmitted by the optical nerve to the brain, to the occipital lobe for evaluation of vision. Let me repeat again in summary. In summary, I'm saying, as I'm illustrating the critical points, the first thing that happens is the process of reflection. So light is reflected by an object within the field of vision. Because now light which is reflected, when it reflected, light moves in a straight line. So this light needs to be refracted. So the next concept is the concept of refraction, which is bending of the light rays that are moving in a straight line. So the light rays are going to move successively through the conjunctiva, the cornea, until they reach the lens. The lens is now going to refract or bend the light rays and focus them on the retina, on the part called the macula lutea, which contains the photosensitive pigments or the receptors of vision. So there is going to be stimulation of the photosensitive pigments, and electric impulses are going to be generated. When the electrical impulses are generated, they are going to be transmitted by the optical nerves. And these optical nerves, we have two types of retina, which is the nasal retina and the other part of the retina. These are going to be to decussate the optic chiasma before reaching the visual center. At the visual center, this is where vision is going to be perceived. So in summary, this is the physiology of sight. So you must master the concepts. The concept of reflection, how light is reflected by an object of the field. The concept of reflection, how light is reflected by an object within the field of vision. The concept of refraction, how light is going to be bent, refracted, and focused on the retina. The concept of stimulation, how the photosensitive pigments in the retina are going to be stimulated. And then the generation of electrical impulses and the transmission of those electrical impulses to the visual center in the occipital lobe, where vision is going to be perceived. In simple terms, this is physiology of sight. Until next time, thank you so much.
I want to speak to you as a leader in the house of God. One thing that I want you to master is that leading in the house of God is totally different from leading in other leadership paths or cycles. You are anointed by God, not appointed by man. You are a leader by God's design, not by man's desire. Your leadership is a divine calling, not a desire of man. It's not a human undertaking. So whatever you do is spiritual. It comes from God. You are there to be an assistant of Christ, not to be his substitute. You are there to lead the children of God so that they are able to be reinstated back into paradise. So your message should focus on critical issues that nourish the human soul, not only focusing on tithe. So your sermon should be based on truthfulness and on these critical issues that draw the children of God closer to their Maker. Things that can take them to paradise, not earthly things, not just prosperity. prosperity in paradise is good, not just earthly prosperity. This doesn't mean that people are supposed to suffer on earth. They are supposed to live a blessed life. People like Abraham were blessed. People like Solomon were blessed. People like King David were blessed. But this doesn't mean that people are supposed to focus on materialism and forget the critical issues that are to do with the purity of the human heart, that are to do with holiness, and to leave things of the earth and focus on critical issues that draw the children of God closer to their Maker. Because God is holy. Human beings can never be holy. It's impossible. But they should strive to be there. Because unholiness is disgusting in the eyes of the Lord. So as a church leader, you must be that person who is a facilitator of the word of God, the helper of Christ, a person whom the followers will look to when they fail to resolve their differences. You must be their last resort. They must rely on you. Yes, it may happen that they may reject you and eject you, but God is going to inject you His Spirit and project you as a vessel that is going to save this world from the devil and the snares of Satan. You are a critical vessel in the spread of the gospel of the Lord. And because of that, you have to ensure that you're a true ambassador of Christ. Because the moment you scandalize the church of God, you have also messed up and smeared the character of Christ. So the character of the men of God should resemble the character of Christ. They should see Christ in you. They should see God in you. You are the resemblance. You are the Christ which they see. So in you, they must see the goodness of heaven and the goodness of the man of God. Until next time, thank you so much.